We're now going to look at the first and the second derivative. You know already that when a curve is given as y and you differentiate it, you find dy by dx. Or if the curve is given as a function, in other words f of x, well then when you differentiate it you're finding f dashed x. Now dy by dx or f dashed x are also called the first derivative. So if a question says find the first derivative, that means you're either finding dy by dx or f dashed x. Now the first derivative is also known as the general gradient of the tangent, which we know already. It's also known as the rate of change of the gradient, and it's also known as the gradient function. So just familiarize yourself with those three statements. They all mean the first derivative, dy by dx or f dashed x. There is also something called the second derivative. And the notation for the second derivative is d2y by dx squared. Just note I said d2y, I didn't say d squared y, d2y by dx squared. Or if the curve was given as f of x, then the second derivative would be f double dashed x. Now how you get the second derivative is you differentiate the first derivative. So you differentiate again. So imagine you start with your curve y, you would differentiate it to get dy by dx. You would then differentiate dy by dx to get the second derivative, d2y by dx squared. So we're going to look at a few examples now which involve getting the first derivative and getting the second derivative, and also subbing values of x into them. So let's look at our first example, example 1. So example 1, it says, given that f of x is equal to 2x plus 3 upon x minus 1 upon x plus 5, find part A, f dashed x. Now, f dashed x means the first derivative. So in other words, you're differentiating the original curve, which is f of x here. So we're differentiating. But the problem is we cannot differentiate, as you know, because there's brackets present. We've got to get rid of them. So copy out your curve, f of x, first. Now we're going to get rid of the brackets. Now there's 3 of them, so a good idea would be, I always put brackets around the last 2 brackets. I insert brand new brackets around the last 2. And then what I'm going to do is multiply the 2 brackets inside the brand new brackets, and then multiply the result by 2x plus 3. So I'm going to keep 2x plus 3 outside for now. So we'll multiply these 2 brackets together, so we're going to get x squared. We're going to get 5x minus x is going to give us plus 4x. And then minus 1 multiplied by 5, that's going to give us minus 5. And then put the brackets back in. So now what we're going to do is multiply the remaining 2 brackets. So we're going to start off with 2x in the first bracket, and we're going to multiply it by every single term in the other bracket. So if we do that, we're going to get 2x cubed. We're also going to get 8x squared. And we're also going to get minus 10x. Okay, next plan is we're going to multiply the plus 3 in the first bracket by all the terms in the second one. So we're going to get plus 3x squared plus 12x, and then we're going to get minus 15. Okay, tidy up. So we're going to be left with 2x cubed plus 11x squared plus 2x and then minus 15. So that is what our curve is, our original curve f of x, once we've got rid of the brackets. Now we're in a position to differentiate. So part A, it says find f dashed of x. So f dashed x means we're differentiating. So f dashed x. So differentiate our first term, we're going to have 6x squared. Differentiate our second term, we're going to have plus 22x. Differentiate an x term where the power of x is 1. Remember, you're just left with its coefficient, plus 2. And then remember, when you differentiate a number term, it just disappears completely. So there's our answer for part A. Really straightforward. We've found the first derivative f dashed x. Part B then says find f dashed of 1. Now, what that means is we're going back to the first derivative equation, if you like, and we're replacing everywhere we see x with 1. So that's going to give us 6 times 1 squared plus 22 times 1 plus 2. So tidy that up. 1 squared is 1 times 6 is 6. So we're going to have 6 plus 22 plus 2. That's just going to give us 30. And that's our answer for part B. F dashed of 1 is just equal to 30. Okay, part C then says find f dashed of x. So that means we're finding the second derivative. So part C, we want f double dashed of x. So that means we are differentiating the first derivative. So if you go to part A is our first derivative. So we're going to differentiate the right hand side now of our first derivative. So if we differentiate again, you're going to multiply this term by its power. So you're going to get 12x and then subtract 1 from the power. So you're going to end up with 12x to the power of 1. Differentiate plus 22x. Remember, if the term has x to the power of 1, you just get rid of the x and you're left with its coefficient. So we're left with plus 22. And then remember, when you differentiate a number term, it disappears. So that's our answer for part C. That is the second derivative, and it's equal to 12x plus 22. And you get the second derivative by differentiating the first derivative. Okay, part D then says find f double dash 2. So that means we're replacing everywhere we see x in the second derivative with 2, and we're getting a value for it. So part D, f double dashed of 2. So that's going to give us 12, and then replace x with 2, and then we're adding on 22. So 12 multiplied by 2 is going to give us 24. 24 plus 22 is going to give us 46. So that's what f double dashed of 2 is.